Hello everyone, this is Zubair and you are very much welcome to this course in microwave imaging. So in this slide we'll briefly explain about what is microwave imaging. So generally when we think about the microwave imaging, there are few questions that comes around the mind. So the first question, the first very basic question is basically what is imaging. So imaging is basically can be rudely classified as a visual representation of something by means of detector or electromagnetic beam. So this is one kind of definition of the imaging, and the second one, the question is what is microwave. So generally, EM spectrum lies from very less radio frequencies to say up to visible and ultraviolet X-ray and gamma rays. So in the spectrum, the specialized wavelength range from 1 meter to 1 mm is basically called as a microwave. And then there are two questions comes into the mind. What about the microwave imaging and direct versus no problem? That these are the questions when you are working in this domain, then you might have some idea about this. So let me give you a hint about these terms. The inverse scattering is basically you can think of the scenario where you are seeing some causes, say some sort of causes, and you are observing those causes and try to estimate some effect of those causes. So that kind of problem is basically called inverse scattering. And in the vice versa, if you talk about the direct problem, is basically when you are aware of the problem and you are just knowing the model and you are calculating the effect of. So these are the direct problems. So we'll discuss these terms in detail when the course will be followed. Okay. So let me come to this historical perspective of the imaging, where in say 1000 AD, a scientist or the physicist called Al-Hazen is basically from the Egypt. He has explained eye as a passive imager and autonomy as well as eye. Actually, in previous antiquity, people have assumed the eye to be an active imager, but later Al-Hazen has proved that this eye, the human eye, is basically a passive imager. So he uses the point projection theory in the 1000 AD, and he also explains the pinhole camera. So I'll show you one picture where you can see what is pinhole camera actually. So the gray model is basically is to plot the image. So in this picture, he shows about the pinhole camera trajectory system. So you can see there is an inverted image in a dark room, can be easily seen from a very small size of aperture through which the incident light is reflected from the scan and being projected on a screen. So let me come to the very fast and crude kind of say the journey of microwave imaging. So as I already talked about, Al-Hazen work in 1000 AD, and he uses the ray model to explain its model of imaging. So after that, Newton actually explained electromagnetic wave as a mechanical particle. Later on, Huygens in 16th century, closer to 17th century, he also proves that those particle is basically having a matter as well as the wave nature. And in 18th century, in the early 18th century, Young proved to be those electromagnetic radiation as a wave, and in the 18th century, Maxwell proves it's an electromagnetic wave, and in the 20th century, de Broglie is basically proved that the EM wave has the dual nature. So this is the brief. So let's come to the point actually. If we can image with the light, so we can also image with the EM waves, because those are all are the EM radiation. So let me explain about what is the inverse scattering that we previously have discussed. The inverse scattering is basically a process of imaging reconstruction of the object by observing the scattering parameter from the object. So let me depict the situations where you have a transceiver system where the EM wave is transmitting and you are reflecting back some information in terms of a scattering parameter, and those scattering parameter and coefficients are being used in the reconstruction algorithm to construct the equivalent image. So this can be easily seen in the examples in the nature as well. So we have seen the echolocation problem where a big fish can send the sound wave and easily locate their predator. So this is the similar problem, but they are using sound wave and we are using here the electromagnetic wave. This is the reflection coordinates questions where I am going to ask a simple questions. Identify whether I is a passive or active imager. Try to think of it and just give a minute to answer this question. Yeah, I already explained about I and already all has in work. So I is a passive imager. It requires separate excitations to image the object. Thank you and have a nice day.